Hi everyone, myself Dr. Lakshmi Prasad, working as an associate professor in the Department of Data Science. So in this video, I'm going to discuss about visual images. So in previous video, I discussed what are the various way of presenting data and then what are the various methods are available. So before going to see that visual images, so what is visualization, so what are the various methods that are available for presenting that visualization, we will see in this video. So very first one is that what is the visual way to show the data. So data visualization is the graphical representation of the information and data by using the visual elements like charts, graphs and maps. So data visualization tools able to provide an accessible way to see and understand what the trends, outliers and patterns in the data, right? So the data visualization is nothing but the graphical representation of information and data by using visual elements. So we are having some elements like charts and then graphs and methods are available to make the data to be visualization. And then so many data visualization tools are available to provide an accessible way to see and then understand the current trends, outliers and the patterns in the data. So what are the three methods of data presentations we are having? That should be next question. So normally we're having three forms of presentations of data. So very first one is that textual presentation and descriptive presentation. Next one is the tabular presentation and diagrammatic presentation. So these are the three various ways of presenting the data. So very first one is that I can able to present the data in the form of text. I can able to present it. That should be can be descriptive presentation. And another one is the tabular presentation. So whatever the data I gather from multiple sources are that can able to present in the form of tabular form. So this is the another way of visualizing the data. And then diagrammatic presentation is the another way where I can able to represent the data in the form of bar charts, pie charts and then graph diagrams, whatever it may be. So these are the various ways of visualizing the data. And next one, that what are the 5 methods of presentation. So normally we're having some popular ways are available for presenting the data while visualizing the data otherwise. So very first one is that line graph is one of the method, and then column chart, box plot, and then vertical bar and scatter plot. So these are the some of the various diagrammatic representations of presenting or visualizing the data. So very first one is that line graph, column chart, box plot, vertical bar, and then scatter plot. And next one is that why this visualization is very important in presenting the data. So data visualization gives a clear idea of what the information means by giving it a visual content through maps or graphs. Okay, so data visualization makes a clear idea. So if I'm going to present the data in the form of text, I can able to suppose if we are having some small amount of data, so that I can able to present the data in the form of text. Suppose if I'm going to use that is some small amount of, suppose if I'm having the data 1 to 10 pages, so at that time what I have to show the data in the form of table. That is the other way. Suppose if I'm having some large amount of data, then I can able to make use of diagrammatic representation is the best way. So the data visualization able to give that clear idea of information by giving its visual contents through either through maps or graphs. So and this visualization makes the data to be more natural from the human mind, so to comprehend, and therefore makes it easier to identify the trends, patterns, outliers within the large data sets. So through the visualization, so why visualization is important means, so this visualization can make an clear idea about the data in the form of trends, patterns and outliers what we're having by taking this large data sets. So that's why the visualization is very important for presenting the data. And then what are the most 5 common formats that are available for visual display of the data? So normally, just now I said that should be column chart. So this is the one of the most common type of data visualization tool, and within this we are having like bar graph, and then stacked bar graph, and then line graph, and then dual axis chart, and Miko chart, pie chart, scatter plot. Like this, we are having some different types of formats that are available to visualize or display the data, right? So bar graph is the first one where you can able to represent the type of bar graph. That should be the bar graph. And stacked bar graph, line graph. Suppose line graph means like this, and then dual axis chart, Miko chart, pie charts. So these are the normal representations or normal visualizations of the data. So what is the data visualization? With example I have to tell. So data visualization means you should able to refer the transforming the figures and as well as the raw data into visual objects. So that may be in the form of points. I can able to represent it, or I can able to represent in the form of bars, or then line plots, maps, etc. Right? So the data visualization means we can able to transform the figures and the raw data into visual objects, right? And by combining this user-friendly and aesthetically pleasing features, these visualizations make research and data analysis much quicker, and also to be most powerful communication tool, right? So by combining this user-friendly and aesthetically pleasing features, so these visualizations make the research and data analysis to make quicker, and then also most powerful communication tool. So these are some of the different ways of visualizing. That should be first one should be maps. I can able to represent it, or I can able to represent the form of frequency polygon, and then I can able to represent the form of pie chart, and then bar graphs. I can also make it as a representation, and then I also make it in the form of line chart. And these are some other different types of data visualization tools. And very first one is that what is the bar diagram. So this bar diagram should be a widely used diagram, and then mostly this should be very easy for the users to draw the diagrams, and then this is going to be compared the categories of mutual exclusive discrete data. Suppose if I'm going to make comparison between two mutually exclusive data, then I have to make use of this bar diagram. And different categories are going to be indicated on axis. We're having two axes, right? X-axis and one axis, and different categories what we're having going to maintain that should be represented on one axis, and the frequency of the data in each category is going to be represented in another axis, and the length of the bar indicating the magnitude of the frequency of the character is going to be compared in this one through the bar diagram. And then the spacing between the various bars should be equal to the half of width of the bar, right? So what is the space we are going to use in between the bar should be equal to the half of the width of the bar. And then this bar diagram is going to be classified in three types, like simple bar, multiple bar or component bar, bar diagram, and then component or proportional bar diagram. So these are the different categories of this bar diagram, right? So the bar diagram should be the widely used one, and then it should be very easy to draw for any kind of applications. And this is only the tool for comparing the various categories of mutual exclusive discrete data. And then the length of the bar indicate the magnitude of the frequency of the character to be compared, and then the spacing between the various bars should be equal to the half of the width of the bar. And these are three types of bar diagrams, like simple, compound, and multiple. So what is multiple bar chart diagram? So each observation is going to have more than one value, so that should be represented by a group of bars, and the percentage of males, suppose I want to make comparison between the percentage of males and females in different categories, or I can able to represent the percentage of width of deaths from heart diseases in old and young age, and mode of delivery in the different female age groups I want to show. Then I have to make use of this multiple bar chart diagram. So each observation have more than one values, right? Suppose if each observation is having two only, then have to make use of this a simple bar. Suppose if the observation is going to maintain more than one value, then at that time I have to make use of this multiple bar chart diagram. And the percentage of males and females, like in different countries, and then the percentage of deaths from the heart diseases in old and young, and then mode of delivery in different female groups, I have to present, then how to make use of this multiple bar chart diagram. And welcome to next one. The next one should be component bar chart. So here the subdivision of the single bar is going to be divided into different sections according to the relative proportion. For example, suppose if the two communities are going to be compared in their portion of the energy obtained from various foodstuff, and each bar is going to be represent the energy intake by one community, and then height of the bar is 100, and it should be divided horizontally into three components. Suppose at that time what you have to make like a protein, fat and carbohydrates of the diet I have to represent, and then each component is going to be represented by different color or shape. So the component bar diagram should be a subdivision of the single bar, which should able to indicate the composition of the total, which is going to be divided into different sections according to the relative proportions, right? And for example, if we're having, suppose two communities are going to be comparing portion of the energy obtained for the from the various food stuff, and each bar is going to be represent intake by one community, and the height of the bar is 100, and it should be divided horizontally into three components. So first one should be protein, fat and then carbohydrate of the diet, and then each component is going to be represented by different color or different shape. And next one should be histogram. So it is the another way of presenting the bar chart. The make the difference between that is if you are going to not maintain any gaps between the bar, then it should be able to call it as the histogram. And this histogram is going to be used for presenting the frequency tables normally, therefore continuous data. Suppose if I'm going to normally up to now till what we have seen should be discrete data. Suppose if I'm going to show that the continuous data, then I have to make use of this histogram is the bar diagram what we are having. It is almost all similar to the bar chart only, but the difference is that there is no space between the one bar to the another bar, and each bar able to represent a class, and its height represents the frequency and the number of cases, and then its width is going to be represent the class interval, right? So each bar represent a class and its height represents the frequency, that should be number of cases, and with the width going to represent the class interval. So this is the way of representing the histogram. And next one is the frequency polygon. So frequency polygon means we should be able to derive from the histogram normally. So by connecting the midpoints of the tops of the rectangles in the histogram. So that should be the frequency polygon. So frequency polygon all the time it should be derived or drawn from the histogram only. So in what we are going to draw this frequency polygon is by connecting the midpoints of the tops of the rectangles in the histogram. And then the line connecting the center of the histogram is called as a frequency polygon. The line what we are going to call what we are going to connecting the centers of the each of the rectangles should be frequency polygon. And then we can able to draw the polygon without rectangles, so that we can able to get the simpler form of the line graph. And then a special type of frequency polygon is that normal distribution curve. So special type of frequency polygon you can able to call it as the normal distribution curve. And the next one is that scatter diagram or dot diagram you can able to call, and this one is also be called as correlation diagram. So it is usually useful all the time to represent the relation between two numeric measurements, and then each observation is going to be is being represented by the point corresponding to its value of each axis, right? So it is going to represent the relationship between two numeric constant measurements normally, and each observation what is going to be represented in the form of points corresponding to the value of each axis. In this negative correlation, the point should be scattered in downward direction, meaning that the relation between the two studied measurements is controversial. That is, if one measure increases and another measure decreases. That should be in the case of negative correlation. And while in positive correlation, the points will be scattered in upward direction only. Suppose in scatter diagram, if I'm going to some diagrams are lying in upside, increases based on the values, and some points are decreases based on the value. Then if it is should be like the controversial in nature, then we should be having negative correlation. Similarly, if the point data what you are going to maintain should be only upward direction only, like in upward direction, then it should be called as the positive correlation. And next one is that line diagram. So this is the another way of representing relationship between two numerical variables, but the points are going to be joined to form the line. Either broken line or the smooth curve is going to maintain, so which is going to be used to show the trend of events with the passage of the time only. Right, so it is the diagram showing the relationship between the two numerical variables, but the points are going to be joined together to form the line. So either in the form of broken line or can able to represent the form of smooth curve. Then it should be the line which is obtained from joining the points, that should be the line diagram, and it is going to be used to show the trends with passage of time. If I want to represent it, then how to make use of this line diagram. And then the last one is that pie diagram. So here the circle is going to be divided into different areas which can able to represent the frequency, which could be divided into different segments, and each segment is going to represent a proportional composition of the total frequency. So here the each segment what I'm going to represent should be proportional composition of the total frequency is the pie diagrams, right? So the pie diagram means where the circle is going to be divided into different areas based on the frequencies or different segments, which should be equal to 100%, and then each segment represents the proportional composition of the total frequency. So these are the some of the various tools that are available to make the data to be visualization actually. So visualization means it should be graphical representation of the information and data where with the help of visual elements like charts, graphs and maps, and data visualization tools is the only accessible way to see and understand the trends and outliers and patterns of the data. So normally you are having three types of data presentation. So first one should be textual presentation and or descriptive presentation, and second one is the tabular presentation and diagrammatic presentation. Suppose the text what we obtain from multiple source, if I want to represent the form of text, so that should be textual presentation. And suppose if the data is going to be represented in the form of tables, that should be tabular presentation. And suppose if I'm going to represent the data what I get from the multiple sources in the form of line chart, bar chart, scatter plot like this, then it should be diagrammatic representation. And so normally we're going to maintain 5 methods for visualization or presenting the data normally. So the first one should be line graph is the one way, and then column chart, box plot, and then vertical bar and scatter plot. These are some of the ways of visualizing the data. So why visualization is important in presenting data, right? So data visualization able to give a clear idea of information by giving it in the form of visual context through maps or graphs. So that is what the visual representation plays a major role in presenting the data. And this should, so that the visualization makes the human mind to comprehend and make it easier to identify the trends, patterns, and outliers within the large data sets. Right? So why it is important is in order to get the clear idea of the information by giving it in the form of visual context through maps and then graphs. So what are the 5 formats that are available for visualize the display of the data? So for that we're having this column chart is the one of the most common type of data visualization tool. So apart from this we're also having like a bar chart and then scatter bar, line chart, dual axis, pico chart, macro chart and pie chart and then scatter plot. So like this we're having some of the various visual tools that are available for displaying the data. And what is the visualization with examples of I want to show it means, so data visualization means normally whatever the data it is going to, or figures is going to be represented in the form of visual objects that should be either it may be a points or bars or line plots and maps. So that should be data visualization. And then by combining this user friendly and aesthetically pleasing features, so this visualization make the research and data analysis much quicker and also to be powerful communication tool. And the diagram what showing it is, it should be the various views of the data visualization. So for first one, what I said previously, that should be bar graph. So where bar graph is the very widely used one, and then it should be able to make comparison between mutually exclusive discrete data, and different categories are going to be indicated in one axis, and then the frequency of the data in each activity or each category is going to present on another axis, and then the length of the bar is going to be represent the magnitude of the frequency of this uh, uh, data. So this is the example of what we're having bar chart. So this should be x-axis and this should be y-axis. So this is the data. So 10, 20, 30, 50 like this. So this is one other example of the bar diagram, and similarly this bar diagram is going to be divided into 3 categories again. So just now what I drawn should be simple bar, and the composite bar diagram means simultaneously if we want to represent 2 data, suppose men data and women data I want to represent, and this should be the composite bar diagram. So then this one should be able to represent the men data, and this one is going to represent the women data in the year 2012 and then year 2013. So like this is the another way of representing the bar diagram. And next one should be component or proportional bar diagram. What should be that? So within the single bar itself, I can able to represent the percentage of men and the percentage of women, and then the percentage of kids I want to represent it means I can make use of this bar diagram like this. So within the single bar itself, I can be able to make the partitions of 3 categories. So this one related to children, and this one related to men, and this one related to women. So like this. So this should be the component or proportional bar diagram, right? So the bar diagram is going to be divided in 3 categories: simple, compound, and then composite, proportional or component. And next one should be multiple bar chart. So here the each observation have more than one value and is going to be represented a group of bars, then it should have to make this multiple bar chart diagram. So the percentage of males and females in different countries I want to know, and then the percentage of deaths from heart diseases in old and young I can able to represent, then how to make those of this multiple bar chart diagram. And next one is the component bar diagram. So here the single bar is going to be divided into different sections, what I should have shown previously, according to the relative proportion. And each community, suppose each two communities are going to be compared with the proportion of energy obtained from various food stuff, then how to make use of this component bar diagram. And this one is going to be divided into different categories, suppose like protein, fat, carbohydrate. So just know what is it. So this is the diagram, component bar diagram, and this should be the proportion of protein, fat, and then carbohydrate. So this should be the component bar diagram. And histogram is almost all similar to the bar chart, but the difference there is that we should not maintain any gaps between the bars. Suppose this is the bar diagram. So if I maintain the gap between the one bar to the another bar, then automatically it should be bar diagram. But histogram is not like this. We should not maintain any kind of gaps in between them. Then it should be called as histogram. And this is the mostly used to representing the frequency distribution of the frequency table class with the continuous data, and each word is able to represent one class, and heights is going to represent the frequency, that should be number of classes, and width is going to represent the class interval. Suppose 10 to 20, 30 to 40, 40 to 50. Suppose in between the class interval, what is the data? And 30 to 40, what is the data? And 40 to 50, what is the data? Like this, I can able to represent the form of histogram is the only way. And next one is the frequency polygon. So this frequency polygon is going to be obtained from histogram by connecting the midpoints of the tops of the rectangles in histogram. Suppose if I draw a histogram like this, so if I going to join the midpoints of the bars of this histogram, then after eliminating the bars what we're having, so that should be the histogram. So right, so the histogram is the way how to draw means. So after constructing this histogram, so once you join the midpoints of the bars of the all the bar in the bar diagram, then the line what I have drawn after connecting the lines is nothing but should be the frequency polygon. So this is also the special type of this frequency polygon will be normal distribution curve. So this is another type of visualization. And next one is that scatter diagram or dot diagram. So here this one can able to call it as correlation diagram. So it can able to be useful and make the relationship between two numeric measurements. So each observation being represented by a point and corresponding to its value on the each axis. That should be the correlation diagram. And this correlation diagram will be of two types, like positive correlation and then negative correlation. So in negative correlation means the points will be scattered in downward direction, meaning that the relation between the two measurements should be controversial. That is, one is increasing, another is decreasing. Suppose if I'm going to draw this, scatter diagram. So this is the way of a view of a scatter diagram actually. So all the data is going to be in the form of dots here. Suppose if all the points seems to be lying in downward direction, so what it means it is having controversial in nature. That means if one value is increasing and another value is decreasing, right? And similarly in positive correlations, all the points is viewed to be upward direction, then it should be call it as the upward direction. That should be another type of scattered or dot diagram. And line diagram, so it is also maintain the relationship between the two variables, and the points are going to be joined together by making use of either broken line or smooth curve. I can able to use it, which can also able to show that the trends of the events with the passage of the time. Suppose if we are having this is the dots I'm writing, so if all the dots are going to be joined by the dashed lines, then it should be can able to call it as the line diagram, or can able to smooth curve I can able to join like this, then it should be line diagram. And the next one should be pie diagram. So here the pie diagram, we are having a circle here. So this circle is going to be divided into different categories, which should be made in the form of 100%, and each segment is going to represent a corresponding value of variable. Like this. Suppose this one portion, what is the proportion rate of x variable and y, z, and then p, q, or like this. The proportion rate is going to be represented here like 25, 35%, and then 65%. The total percentage should be equal to the 100%. Okay. So like this should be the pattern. Like this, we're having different types of visualization tools. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.